Hello, AP Calculus students. This is Mr. McAllen again, and what we're going to go over here is some tricky piecewise functions. There are just two here if you look at this problem, and if you look at the next problem. These are actually old AP questions that they never kind of change really. Well, they do change, but I mean, the basic ideas are all there. They either want to ask us about continuity or does a limit exist or differentiability. So let's just go over just a couple of the rules first before you try it. For continuity, you have to find out if three things happen. The first thing is, does the function exist at where the piecewise function is breaking up? So, or it might be breaking up. So does f of a exist and what's its value? The second thing is, does the limit as x goes to a from the left equal the limit as x goes to a from the right? And for continuity, they would want to see, does the function value at a actually equal what the limit you found in part 2 was? And if it does, then it's continuous. So here are some scenarios. Let's say that the limit from the left doesn't equal the limit from the right. Then you would have a jump discontinuity. And you would find out that your check fails at step 2. Step A would say that you have a function value. Step 2 would say that the limit from the left doesn't equal the limit from the right, so you have a break or a jump discontinuity. So you wouldn't even go on to step 3 because you've already shown that since a limit doesn't exist because of the break in the function, you're discontinuous. Then you have the scenario where you find out the function value exists, but you find out that the function value may be at a different value altogether from what the limit's heading to. So this is where you have a whole discontinuity. So basically you have to check each situation differently. And then sometimes they ask you, after you establish that there's been continuity, is it differentiable at that point? And that would require you just taking your derivative of the left function and the right function and seeing if the derivative value is equal for that value of a. So let's take a look at this first one. I want you to try to find a value of k that would force continuity here. And I'm going to pause it, give you a moment to think about it. And then when I unpause the video, we'll go over it. Okay, everybody, we're back. And what we have here is we're going to first check is for what value of k is a function continuous. So let's first find out what f of 2. We're checking continuity at 2. Let's find out what f of 2 equals. And f of 2 is just going to be, because the function that we use when x is equal to 2 is the top function. We're just going to plug 2 in. And we're going to find out that that's equal to 4 minus 6 plus 9, which will be 7. So that's going to be the function value at 2. Now we're going to check the limit as x goes to 2 from the left. And that happens to be just the same function we're evaluating. So we're going to do the limit as x goes to 2 from the left of x squared minus 3x plus 9, which our first rule of evaluating limits is to plug in the value in. So when we plug in the value, we're going to get 7. So there's no problem here showing that it's continuous from the left, but now we want to try out, is it going to have, what's the limit going to be as we come in from the right? So in that case, I'm checking the other half of the limit, which is the lower function. So that'll be k times 2 plus 1. Now, I don't know what the value of that is. It all depends on what k is. So we actually can force continuity by setting this side of the limit equal to the 7, where we want to equal the other side. And when we do that, we find that k has got to equal 3. So the question said, for what value of k, if any, will make the function continuous? And the value of k that would work would be 3. Take a look at the next question. It asks us to do a bit more. It says, let the function be defined above by piecewise, where c and d are constants. If f is differentiable at 2, what's the value of c plus d? So by them saying it's differentiable, they're saying that it's also continuous. Remember, to be differentiable, your function must be continuous. It doesn't go the other way, where if it's continuous, it's got to be differentiable. So if they say it's differentiable at x equals 2, that means it also had to be continuous. So we have two checks to find what C and D could be. Try it out. I'm going to pause the video, and then we'll come back and do it. Okay, so we're back, and now it's time. Let's check for continuity. So what is f of 2? F of 2, we're going to use the top function, and we're going to plug 2 in. So f of 2 will equal c times 2 plus d. That's what f of 2 is. Now, if we check the limit from the right or the left, we're going to get the same equation. If we check the limit from the right, will be 2 squared minus c times 2. So the limit from the right is going to be 4 minus 2c. So in order to force continuity, these limits have got to equal. So when we do that, we have 2c plus d equals negative 2c plus 4. So now we're in a scenario where we have one equation. We're going to have 4c plus d, because I'm trying to get this equation, is equal to 4. So this is an equation I'm going to use in a moment, but this equation will make the case for continuity. The next thing we're going to do is we're going to check for differentiability. So differentiability means that the derivative of the left has got to equal the derivative from the right. So in this case, the derivative on the left is just what's the derivative of cx, because c is a constant. The derivative from the left is c. The derivative from the right is going to be 2x minus c. So basically we get this equation. The condition for the derivative equaling is 2c must equal to x. Remember, x is equal to 2. So right now, 2c must equal 2 times 2. We're finding out that c has got to equal a value of 2. If c equals 2, then we can find the value for d. We just take that value, plug it back into continuity. 4 times 2 plus d must equal 4. So I would say d has got to equal negative 4, because that's 8 plus something gives you 4. So d equals negative 4. And their question was, what is the value of c plus d? C plus d is equal to negative 2. If I've done my arithmetic right. The calculus is definitely right, but I'm saying choice B would be my answer. Hopefully this video has helped you understand the ins and outs of some tricky continuity questions with piecewise functions. And please send me some comments or let me know if this video was helpful.